Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to another computer science lecture. I hope you guys are doing fine. So we were discussing section number 5, the internet and its uses, of computer science O-Level syllabus 2210. We had previously discussed section number 5.1, internet and www. So today we are going to start section number 5.2, that is digital currency. Digital currency is a form of currency that is available only in a digital or electronic format. It is also called digital money, e-money, electronic currency, or cyber cash. Digital currencies have a utility similar to that of physical currencies. Just like a physical currency, they can be used to purchase goods or pay for services. They also have some restricted use among certain online communities such as gaming websites, gambling websites, and some of the social media networks. They also enable instant transactions that can be seamlessly executed across borders. Sending or receiving money from one country to another is very easy and usually takes around 10 to 15 minutes or maximum half an hour. For instance, it is possible for a person located in the USA to make payments in digital currency to a counterparty residing in Singapore or Malaysia or anywhere in the world, provided that they are both connected to the same network. They can be centralized or decentralized. Now, like we just discussed, digital currencies can be of two types. Either it can be a centralized system or a decentralized one. So first of all, we are going to discuss centralized system, that is known as CBDC, central bank digital currency. Now a central bank, or in some countries it is also known as a state bank, is the bank which is owned by a government, and it basically overlooks all the other banks in a country and is responsible for producing new currency notes, new coins, and so on. In simple terms, CBDC is short for central bank digital currency. It is an electronic form of central bank money that citizens can use to make digital payments or store values, means keep their cash safe inside a vault or a wallet. A CBDC should have three main elements. It should be available digitally, or it should be a digital currency. It should be issued, or it should be backed up by a central bank, and it should be universally or globally accessible. For example, as you can see, a Canadian lumber company sends the payment through their account in a Canadian bank and sends the payment onto a Canadian payment system, and from there it goes to the Central Bank of Canada, and from there it would go to the Central Bank of France, and from there it would go on to the French payment network, and through which it is going to end up into the bank account of a French manufacturer in a local French bank. And this process is hardly going to take around 15 minutes, maximum 15 minutes. Normally this takes around 2 to 5 minutes, and that's it. Whereas if you try to send money physically from one country to another, it can take that is commonly known as bank wire. So it can take around something like 2 to 3 business days or more. So this was centralized digital currency. Another type of digital currency we have is decentralized digital currency, and a very famous form of digital currency of such type is known as cryptocurrency, which is a decentralized network based on proof of work. Means you have to show some proof that you have done some work which is given by the network, and then you can earn that money. Examples of crypto includes Bitcoin, Litecoin, Dogecoin, Ethereum, Leocoin, and so many more. Now cryptocurrency, which is in short known as crypto, as just crypto as well, it is a form of currency that exists digitally or virtually, and it uses cryptography to secure transactions. Cryptocurrencies don't have a central issuing or regulating authority. Instead, they use a decentralized system to record transactions and issue new units, or you can say issue new coins. It is a peer-to-peer system, means it is a system that connects one person directly with another, that can enable anyone anywhere to send and receive payments. It works something like this. In a traditional financial system, means centralized banking system, you send the money, it goes into your bank, then it sends it to another country through one of the famous payment processors, Venmo, MasterCard, Visa, PayPal, OneLink, and so many more. Basically, some central bank is, or one or more central banks are involved over here, and then the bank of receiver finally gets that money and then puts that money into the receiver's bank account. Whereas in the decentralized financial system such as that of cryptocurrency, you send the money, it goes onto a network, and after validation the receiver receives it into his or her wallet. Simple as that. Instead of being physical money carried around and exchanged in the real world, cryptocurrency payments exist purely as digital entries to an online database describing specific transactions. Cryptocurrencies do not exist in any form physically, whereas centralized digital currencies can exist both as physical and digital currency. When you transfer cryptocurrency funds, the transactions are recorded in a public ledger that is known as blockchain. Cryptocurrency is stored in digital wallets. You need to download and install or create an online wallet in order to hold on, or you can say store cryptocurrency. The first ever cryptocurrency was Bitcoin, which was founded in 2009 by Satoshi Nakamoto, and we still don't really know who that guy was, but he gave us a very good system of blockchain and cryptocurrencies. And up till now, Bitcoin is at the top of the chart. It is the most, you can say, most expensive, and it is the best known currency in the cryptocurrency in the world so far. So how does cryptocurrency work? Cryptocurrencies run on a distributed public ledger that is called blockchain. A ledger is basically an accounting term. It refers to a format or a page that records multiple financial transactions. A record of all transactions is updated and held by currency holders. Units of cryptocurrencies are created through a process called mining, no matter whichever crypto you are buying or you are holding. If you want to create new units for that currency, then you need to do mining. Mining is a process which involves using computer power, basically idle computer power, to solve complicated mathematical problems. And when you solve those mathematical problems, then as a reward the network gives you some of the coins or generates some coins of that cryptocurrency. But if you don't want to do mining, because it stresses your computer a lot and it can cause hardware malfunction, so what you can do is you can buy or sell cryptocurrency from brokers, from websites known as crypto exchanges, and you can store and spend those cryptocurrency by storing them into one of the cryptographic wallets. There are many wallet providers depending upon what type of currency you would like to use. For Bitcoin there is a different wallet, for Monero there is a different wallet, and so on. Blockchain. Blockchain is a type of shared database that stores data in blocks that are then linked together via cryptography, hence creating a chain of blocks that is known as blockchain. As new data comes in, it is entered into a fresh block. Once the block is filled with data, it is then chained on to the previous block, which makes the data chain together in chronological order. If a hacker tries to alter transaction of a block, its hash will be altered, hence all blocks after that will be lost and the chain will be broken. Thus, this system is considered hack-proof. The first block in a chain doesn't link to a previous block, and it is known as genesis block. Genesis is a Greek word that basically means origin. So if you are not familiar with the word hash, then there are certain algorithms which are used in encryption, which if you enter some text or file into it, so they convert it into a one-way irreversible gibberish string. That output string is known as a hash. Whenever you would enter the same message into that algorithm, it would always produce the same gibberish set of characters or same random set of characters, but the system is so complex that you cannot reverse engineer it. It is not like encryption that you can use a certain key to convert the hash back into the original message. So a blockchain, or every block on the blockchain, basically consists of three things. One is the hash, one is the previous hash, and then there are multiple transactions. Once all over here in the diagram, each block only shows two transactions, but in real world, this is just an illustration. In real world, we have around 10 to 25 transactions on one block, or you can say multiple transactions on a single block. So once all the transactions are filled, then the hash is calculated by converting all the transactions into a hashing algorithm. Now if you change the value, like this is 0 multiplied by a, even if you slightly change this one of these a's into b, then this value of hash abc123 would change and you would not be able to get it back. So if a hacker tries to alter a transaction on a block, like he wants that instead of money going from a to b, the money should end up in his account, then obviously he'll have to change the value of the transaction or the details of the transaction, and when he does that, then this hash value would change, and the blocks after this block would be unable to link to this, because this value would change and they would be looking for this value to connect to. Hence all of the chain would be lost and it would be recalibrated or re-recorded. Hence the hacker would not be able to gain his purpose. This is the first block in the chain, and as you can see, it does not have a previous hash or previous block hash. It's 000 because there is no block before this. This is the first block in the chain, hence it is known as the genesis block, whereas rest of the blocks are 1 2 3 4 whatsoever. Every block contains the link to the previous block unless and until it is the genesis block. Now in exam you would get a question something like, you would be given a blockchain and this previous block would be missing, and arrows would be drawn, and you simply would have to write the value by looking at the hash of the previous block. Because the transactions value you cannot calculate, calculating a hash is way beyond the scope of your syllabus, so this only leaves us this, that you would be given a chain of blocks in exams and you would have to write down the previous block hash by looking at the previous block in the drawn chain. Each new user on the network gets a copy of all approved transaction on the network, means every new user gets a copy of the whole blockchain. Different types of information can be stored on a blockchain, but so far the most common use has been as a ledger for financial transactions. In Bitcoin's case, blockchain is used in a decentralized way, so that no single person or group has control. Rather, all the users collectively have control over the blockchain. This is not just for Bitcoin. For each and every cryptocurrency, the same is happening. Every cryptocurrency so far is decentralized. Decentralized blockchains are immutable. That means they are irreversible and you cannot alter the data or the transaction which have been once recorded on the blockchain. So this is a diagram to make you understand how blockchain works. A wants to transfer money to B, so the transaction is represented on a block. That block is broadcasted to every member on the network. All the members on the network validate it, and then it is linked on to the previously existing blockchain. And as soon as the block is linked on to the blockchain, B receives money from A into their wallet. This process usually takes around 15 to 30 minutes because the transactions or the blocks of cryptocurrency are very heavily encrypted, and their validation takes a lot of resources from the network. Possible applications of blockchain in automotive: consumers could use the blockchain to manage fractional ownership in autonomous cars, means multiple people can buy a single car. Financial services: faster, cheaper settlements could save billions of dollars from transaction costs while improving transparency, as you cannot alter the data. They can be used in voting systems so that votes casted are very much transparent, and they are irreversible, and they are verifiable. In healthcare, patients' encrypted health information could be shared with multiple providers without the risk of privacy breaches, or without the risk of what you can say data security, or without the risk of that without any risk of privacy, without any privacy issues. So this is it for our section 5.2. I hope you have understood everything. Feel free to contact me. If you have any problem, do give me comments so I know how was the lecture. Take care. Allah Hafiz.